Welcome back. In this video, we are going to look at another example for minimization of a DFA. So here we see a DFA with 5 states Q0, Q1, Q2, Q3, Q4, and the input symbols are A and B. So we have the state transition table like this. We have already drawn the state transition table. So let us see how we can start with the minimization process. So the first step is separate out the non-final states and the final states. So non-final states and final states. So non-final states are our Q0, Q1, Q2 and Q3. So they will form one partition, and we have only one final state here. So Q4 will be in a separate set. Now this was our 0 equivalence. Next, let us look for 1 equivalence. So 1 equivalence, we will start from our first state, our first partition Q0, Q1, Q2 and Q3. So let us take two at a time. Q0 and Q1. Let us take Q0 and Q1. Let's go to the transition table. So Q0 and Q1, Q0 on A goes to Q1 and Q1 on A also goes to Q1. So it's the same state. So no problem. Let's look for B. For B, Q0 goes to Q2 and Q1 goes to Q3. Now we have to check whether 2 and 3 belong to the same set or not. So if we go back here, we find that 2 and 3 are in the same partition. 2 and 3 are in the same partition. So our Q0 and Q1 will appear in the same, in the one equivalence. They are equivalent. They are one equivalent. Now let us take Q2. So Q2 we can compare with Q0 or Q1. Let us take with Q0. So we are now going to look at Q0 and Q2. So Q0 on A goes to Q1, Q2 on A goes to Q1. Same set, no problem. Then we take Q0 on B goes to Q2, Q2 on B also goes to Q2. Again, same state. So no problem. So Q0 and Q2 are equivalent. So here we will write Q2 will also be equivalent. Now if you check for Q1 and Q2 also, you will find that they are equivalent. Because since Q0 and Q1 are equivalent, so and Q0 and Q2 are equivalent, so 1 and 2 are also equivalent. Now we are left with 3. So 3 again, now we can check with any of these 3 states, 0, 1 or 2. So let us check with again 0. So I'll just remove these markings. So I have Q0 and Q3. So Q0, you see, on A goes to Q1, Q3 on A also goes to Q1. So fine. Now we have to check for B. So Q0 on B goes to Q2 and Q3 on B goes to Q4. But now you see Q4 is not in this set, So you can say that Q3 and Q0 is not equivalent, or these are not equivalent. And since Q3 is not equivalent to Q0, it is also not equivalent to Q1 and Q2. So what we will do, we will create a separate partition for Q3. Okay, so we have created a separate partition for Q3. And here in the final state already only one state is there, so there is no question of finding equivalence since it is a single state. So you have Q4. Next we will compute. So this is the end of the second step. We have found one equivalence. Next we will look for 2 equivalence. So 2 equivalence, again we will check for this state or this partition. So Q0, Q1, Q2. So let's look at this. So Q0 and Q1. So Q0 and Q1, let us say for Q0 on A goes to Q1. Q0 on A goes to Q1. Q1 on A also goes to Q1. Fine. So these two are equivalent. Look at B. So Q0 on B goes to Q2 and Q1 on B goes to Q3. Now, in the previous state, Q3 has moved to a different state. So Q2 and Q3 now are in two different sets. So Q0 and Q1 on B, they are moving to two different sets. So Q0 and Q1 will not be equivalent. So we will separate out Q0 and Q1. So Q0 I'll leave here and Q1 I will put it here. Okay. Next, let us take Q2. We are left with Q2. So Q2 here. So Q1. So we are looking at Q0 and Q2. So Q0 on A is 1, Q2 is also 1. So fine. Q0 on B is Q2 and Q2 on B is also Q2. So Q0 and Q2 are equivalent. Okay, and Q1 forms a separate set here. And Q3 again, it's a single set. Okay, and we have Q4 out here. Single element sets we are not going to check for equivalence because it's alone. So now I have these partitions Q0, Q2, Q1, Q3 and Q4. So 4 sets I have. Now we have checked for 0 equivalence, 1 equivalence, 2 equivalence. Do we need to check for 3 equivalence? Yes. So we'll look at 0 and 2, Q0 and Q2. So Q0 and Q2. So Q0 on A is Q1, Q2 on A is also Q1. And Q0 on B is Q2, Q2 on B is also Q2. So Q0 and Q2 are equivalent. So let us write it here, Q0, Q2. And the rest are all single element. So we keep them as it is without any change. Now you see from 2 equivalents and 3 equivalents, the sets remain unchanged. So since it remains unchanged, we will say that we have reached the end of the minimization process. We cannot minimize any further. And so we will construct our transition table. So we have the sets Q0, Q2, Q1, Q3 and Q4. So our transition table will be something like this. Q0, Q2, then Q1, Q3 and Q4. And our inputs are A and B. So Q0, Q2 on input A, Q0, Q2 on input A goes to Q1 and on input B goes to Q2, both of them. So Q1 and this is Q2. Now Q2 is already coming with Q0, so Q0, Q2. Next, for Q1. So Q1, the rest remains the same. Q1, Q3 and Q5. So Q1, Q3, Q1 and Q3. For Q3, it is Q1, Q4. Q1, Q4. And for Q4, it is Q2, Q2. So Q2 is not alone now, so it is Q0, Q2, Q0, Q2. So we have our minimal DFA. We will get something like this: Q0, Q2. This is one state. This is the original start state, Q0. So we start from here. Then we have Q1, we have Q3, and we have the final state, Q4. And the transitions are like this. On B, it goes to this. On A, then Q1 on A is itself. Q1 on B goes to Q3. Q3 on A comes here. Q3 on B goes to Q4. Q4 on B goes to this. Q4 on A goes to this. So this is our minimized DFA.